All right, everybody. I think we're ready to go. Thanks for joining us, everybody. To start things off, I want to thank you all for joining us today for today's webinar, which is Optimizing Your Plant with Digital Twin Technology. This is the first webinar of our Next Step webinar series for 2021. My name is Philip Glennie, and I'm joined here today by some experts from Siemens, Noam Ribon and Jithan Tellis, and we're very grateful to have the two of them here with us. So here's a quick agenda for today. We're going to start off with a quick introduction, and we're going to talk about the plant level digital twin, which is really the showcase for today. We're going to look at some success stories. And then we're going to talk about virtual commissioning, and basically what we're talking about there is when your simulation is being driven by real PLC code, so you can validate that code in the virtual setting and even download and upload that to your real world hardware. And then in the end, we're going to end with a Q&A. Next slide, please. So here we're going to start with a brief introduction of digital twinning solutions. And I am Philip Glennie. I'm the Director of Marketing and Sales here at Long-Term Technology Services. And so next slide, please. So I just want to start off with a little bit about our team here at Long-Term Technology Services. So it is really our mission to be a trusted partner for exploring new digital solutions that are going to help you lower your costs, lower your lead time, increase your production quality, your efficiency, and basically at the end of the day, make your company more profitable. And we're really doing this at two levels. First is that more long-term level, if I can use the expression, by helping you build a common digital thread that runs through a number of industry solutions that this can span from your production design, your product engineering, through to your scheduling, and even your plant management, which we're going to be looking at today. But it's also our mission to really meet companies where they are. We know that small, medium-sized companies, the ones we work with, you need that short-term benefit, right? Which is why we also offer the upfront support and the training and the consulting that's going to help you hit the ground running with any sort of new digital investment. And our mission is really to help you compress that payback period so that you can show real ROI within just a couple months of one of these new digital investments. And we're also a very, very proud Siemens Smart Partner and Technology Partner, and we're very proud for the support we're getting from Siemens on this webinar today. And we really specialize in helping those small and medium-sized companies reap the full rewards of digital industry software. Next slide, please. And we want to make sure that you're sure to join us at our next webinar tomorrow on robotic simulation, and we're going to be joined by Steve Cardozo of InCycle Automation. And we're really looking forward to showing you how offline programming and robotic simulation can really reduce your robot programming times by as much as 60% is what we've seen in some cases. So, and at the end of this, we will also send out a link for that tomorrow, so you have an opportunity to join us for that as well. Next slide, please. So I want to start off by talking about some key trends here. As many of you know, there are a number of trends that are forcing companies to become leaner, smarter, more agile all at the same time, while somehow increasing the quality of your products. And some of those trends are what you see listed here, right? You're looking at consumer-driven customization, and then here you've got complexity, quality, personalized. All of these things are mounting pressures, and the pressure to somehow do all of this while lowering costs and lead time is getting really intense in many cases. So next slide, please. And so we really believe that the holistic digital twin, which we'll be talking about today, is the way to meet these trends and the accompanying demands. So let's talk about what we mean by this. Well, if you think about, because digital twin in some cases can be a bit of a buzzword, so here's what we mean by it. If you think of traditional simulation, you're usually thinking of, say, a geometric or a kinematic simulation, and it's pretty hypothetical in nature. It's not the reality. But with a digital twin, you're really looking at a virtual replica of a product or machine that goes into the realms of, electrical engineering, mechatronics, thermal, kind of you name it. It's using physics-based modeling, and it also has the ability to be driven by real PLC code and to validate that code. So now you're talking about a really different kind of next-generation simulation that really is offering you a stand-in for the real-world object, and it can be connected to that object in real time through sensors to measure its performance as well. And that has big implications for the way we do things in manufacturing and in automation. Next slide, please. So it's really this approach that allows you to shift left and to bring more of your manufacturing concerns into that design and engineering stage of your product lifecycle. And you can do this by performing a lot more work than you could previously in a virtual setting, with that confidence that when it comes time to manufacture or commission a product, you can do that error-free. So basically, you're no longer stuck creating expensive real-world prototypes only to find out that they don't work. And you're not commissioning real-world production lines only to find out that you're going to get those collisions and interferences that you have to address after the fact, usually at high cost and big loss on your lead time. So that can all now be done in a virtual setting for a lot less cost and much less time, with greater accuracy and efficiency. Next slide, please. So once you've decided to work with a digital twin, it's then really a question of scope, right? Like, what is the scope of the digital twin product you're looking at? And this runs all the way from, plant level simulation down to the level of the individual machine, the PLC that is driving that machine, the hardware that you want to hook up to that virtual commissioning project, that digital twin. But for this webinar, we're going to focus on that top level, which is really the plant simulation level, and all of the associated opportunities with that. And in the other webinars, as part of this 5-part webinar series, we'll focus on some of those other levels. So for example, in tomorrow's webinar, we're going to be moving more toward the robotic station or the line as we move down that funnel, as you can see. And so with that, I'm going to turn things now over to Jithan Tellis. And we're really grateful to have you here, Jithan, so take it away.
So our customers in all industry, from bottle filling to our shipbuilding industry, is using plant optimization solution. Siemens itself is using plant optimization solution for turbine building, power transmission, industrial PCs, and healthcare sectors. Some of the key benefits realized by our customers include substantial increase in throughput, reduction in logistic cost, and significant reduction in cycle times. Our discrete event simulation is a powerful simulation tool where you can build accurate digital twin of your manufacturing as well as logistic facility. It could be for greenfield facility or for an existing system, so-called brownfield facility. Flexibility. Now, using digital twin, you can check flexibility of your production system to meet the future needs. Example could be you want to check feasibility study for new production introduction in your line. Throughput. Increase throughput by eliminating bottlenecks and by reducing throughput time. Next, we might be interested in knowing or right sizing the resources that we have in the shop floor. For example, it could be a conveyor system, it could be robots or multiple machines. If you go with a smaller number, you may not be able to achieve required throughput. On the other hand, if you're over generous, you'll end up spending excess capital. You're also interested in reducing the footprint. How can we do that? By optimizing the layout, you can now reduce the footprint. Work in process. Now you might have lots of work in progress in between the stations, or the raw material is stored somewhere. You want to optimize it. You want to minimize it, actually, in fact, meanwhile not affecting the actual production process. You want to be able to detect different interdependencies so that you can take an informed decision. Once we take that informed decision, our strategy is going to be, we want to optimize our strategy. This then leans on the automation world, like the PLC, which might be controlling your equipment or the robots or process. Now what we can do is we can use this PLC, connect to a digital twin of the model, and drive those models and test the control strategy in digital twin itself. Once your production shop floor is up and running, or with the existing shop floor, what we can do is we can take data from the shop floor and put back that data into digital twin and see what's happening exactly in the shop floor. Is there any errors? Is there any issues that you want to resolve? So with this, I'll be covering three key aspects of plant optimization solution, which can bring significant benefit to users. We will see how you can be profitable by right-sizing the resources, by optimizing the process, and by leveraging the power of closed-loop digital twin. Profitability. We want to be profitable. To be profitable, we have to minimize our capital and operating expenditure. It could be for production line or it could be for logistic facility. Without jeopardizing required output is a key factor here. This can be achieved by effective utilization of existing resources and minimizing non-value added activities. So in this example, you're going to see how you can increase the utilization of existing resources, how you can get higher return on capital employed. Select the best strategy for your production line. Let's begin. This is our production digital twin of the plant. We keep it up to date. This is our kitting area. Kits have become very complex, leading to much rework. As a result, lowering key performance indicators like utilization and return on capital employed. We will see three different use cases. First, we will see a use case where we are going to add 2 additional workers to the existing shift. We'll see what's the effect on adding 2 more workers to the existing shift. The current baseline utilization is 70% and return on capital employed is 3%. Now we can fast forward the simulation to save us some time. This is the advantage of using solution. We can see the return on capital employed has doubled and utilization has gone up. Now, how about considering second strategy? In this strategy, let's take three shift and we will check whether our utilization will go up or the return on capital investment employed has gone up. Once we run the simulation, we can fast forward and run the simulation. In this case, we are running more parts. However, utilization has not gone up. In fact, it's lower, even capital on return on capital investment. At this point, we can completely rethink our strategy. This is the third point. How about bypassing the manual kitting and making it automated kitting? The simulation shows there are no parts running through the manual kitting operations. We simulate zero kitting rework bypassing the manual station. This allows us to access potential for automatic kitting. After simulation, digital twin clearly shows the preferred solution, that is an automatic kitting, as you can see at the end. The return on capital employed has increased threefold in automation case and in 2-shift production process. By using our solution, you can gain confidence in your investment, lowering operating costs. To summarize how we can be profitable, the simulation tools that we are using allows us to evaluate different strategies in digital twin itself, and we can further fine-tune the selected strategy. This translates to saving considerable financial resources as well as time. Process optimization. Using our solution, you can test different production scenarios, select the best scenarios that is suitable for your production process. Finally, implement optimized solution in your production or logistic facility. In this example, we are going to see how to detect underutilized resources first. Second, how to optimize a resource that we have selected to get a higher throughput. This is our electronic assembly line. We have a problem with not meeting delivery. We only produce 1,000 parts per day. By analysis, it's found out that 30% of the time a worker is waiting, as you can see on the graph. Now, Running various scenarios, we can test out various scenarios. Running various scenario in digital twin allows us to arrive at the strategy that increases the output by 80%. As we can see from baseline 1000 parts, the throughput has gone to 1794. This is not this is a usual case where which customers have realized lots of benefit out of our solution. To summarize, by using our solution, you can optimize the production process. This optimized solution results in effective utilization of existing resources and substantial reduction in terms of inventory. Finally, we'll see once your plant is operational, your equipments are up and running, how you can leverage this digital twin simulation. We can take data from the actual shop floor and put that data back into the digital twin to see how production is performing, detect the issues or errors, and take corrective measures in digital twin itself. Once we have come up with an optimized strategy, that solution or that strategy can be implemented in real production floor. How we can do that? On my right hand side, you can see a real production facility from where data is taken using IoT platform. In this case, MindSphere, our platform is open. In this case, we are using Siemens platform. Once we take that data from the shop floor, we can put it into the digital twin, that's our solution, and see what problems are. In next example, we are going to see that. In this example, we are going to see exactly how you can take IoT data from shop floor and feed back into a digital twin to detect issues in the actual shop floor and to come up with a solution that is best suited. Let me go ahead and play this video. We launched closed loop discrete event application from a MindSphere, our IoT platform. Yesterday, we saw a drop in production of around 100 cans. We also noticed suspect behavior of a conveyor. We will use conveyor production data or IoT data collected from yesterday's by MindSphere to create a study for that conveyor. Ingesting production data by a digital twin will transform to a closed loop digital twin. We will want to review what happened, but more important, fine-tune the system to compensate for a loss of production until conveyor is fixed. The conveyor might have triggered interdependencies beyond packaging department. So we use digital twin of our complete production. We add MindSphere interface to our digital twin, load the study, and apply it to the model. Here is the sum of the IoT data that is ingested. Now let's run the study. The closed loop digital twin uses IoT or conveyor to simulate its behavior. A closer look here confirms our suspicion that conveyor is failing. And we can clearly see impact on the production. The production rate is going down. By the actual production rate is 10,465 cans. We apply an adjustment in this case. As you can see, the production has gone down. We'll apply adjustment in speeding up the minor feed line conveyor to compensate for the loss. This is how we use MindSphere IoT and closed loop digital twin to fine-tune our production, adapting to the daily changes. The closed loop digital twin will confirm we can apply our changes to production and compensate for the loss of 100 cans. So the new data that is coming up is 10568, that's 100 cans improved throughput. To summarize the closed loop digital twin, using closed loop digital twin, you can bring IoT data from shop floor into a digital twin to see where real problems are, validate solution in digital twin, improve your existing production process. what we have seen to in all the slides is we have seen how you can increase your profit by minimizing capital expenditure as well as operating expenditure, tweak the production system to get higher throughput. Finally, how you can utilize IoT data in your digital twin to see what's happening in actual plant, which could be a potential service offering by a line and machine builders to OEM. We are going to see a real world example of small and medium scale industry. Mectop falls under a small and medium business category. They are based out of Switzerland, a equipment building company specialized in food and beverage processing solution. Key challenges faced by Mectops are delivering a complex conveyor system in time, making intelligent complex design to meet ever-changing customer demand, and finally, verify feasibility of solution, including proof of concept during the sales process. Using our solution, Mectop was able to build and simulate digital twin of a complex logistics system to validate three key aspects. First one was plant capacity, second, optimize control strategy, and finally, to plan ahead well in advance. They gain confidence of customer by showing what the final system will look like and that it will perform as expected during the proof of concept phase. All the activities, right from the design till the simulation, they were able to complete in plant simulation within 60 days. This cleared way to secure a customer contract worth approximately $3 million. Key factors to their success was building a digital twin of a complex system using plant simulation and delivering the solution in time. With that, I'll turn it over to Philip.
Thank you very, very much, Chetan, for that. And with this, we're going to turn it over now to Noam Rabban, who's going to show us a little bit about the virtual commissioning side of things. Noam, I'll turn it over to you.